Alright, hello and welcome to today's Explore More. So today we're exploring more about the equations of parallel and perpendicular lines. So you've been talking a lot about slope and a lot about the equations of lines in your Algebra 1 classes. But when we dive more into some Algebra 2 and even some geometry next year, we talk a lot about parallel lines and perpendicular lines. So let's just quickly have a quick definition of each. So parallel lines, you may remember back in 8th grade, you talked about parallel lines, and a lot of times you say things like lines that never intersect, and that's true. But today when we're talking about a pair of lines or a set of lines, the key for parallel lines is that they have the same slope. So the reason they don't intersect is because parallel lines have the same slope. And so if you think of a line that maybe has a slope of, up 2 over 3, a parallel line, a line that has the same slope, if it also is up 2 over 3, it makes sense that they're not going to intersect because they're increasing at the same rate of change. Okay, so parallel lines have the same slope. And then perpendicular lines. So these are lines that intersect at a right angle. So they cross each other, they intersect at a right angle. A right angle is a 90-degree angle. A 90-degree angle. Okay, so if we graphed some perpendicular lines, not only would they cross, but when they cross, they would make a perfect right angle, a 90-degree angle. Okay, and so you can see their slopes are definitely not the same, but they are connected to each other. So perpendicular lines, we say that they have opposite reciprocal slopes. So we talked about the word reciprocal this year already when we were solving equations with fractions. So reciprocal means we're going to flip the fraction upside down. Opposite means that if it was positive, now it's going to be negative. If it was negative, now it's going to be positive. So just for a couple of examples, let's say we have a line that has a slope of 2 over 3. A line that is perpendicular would have a slope of negative 3 over 2. Or if we have a line that has a slope of 1 over 5, it's a line that's perpendicular would have a slope of negative 5 over 1, or negative 1, or negative 5. And then if we have a line that has a slope of like negative 3, then a perpendicular line would be positive 1 over 3. Okay, so parallel lines have the same slope. Perpendicular lines, they intersect at a right angle, and when they do, their slopes are opposite reciprocals. Okay, so the problems that you're going to see today are going to look like this. It says write the equation of a line that is parallel to the line y equals 2x minus 7, and it goes through the point 4, 10. Okay, so we're trying to create a new equation, find a new line that's parallel to 2x minus 7, but goes through this point 4, 10. Okay, so what do we need? We have a point. In order to write the equation of a line, we need either a y-intercept or a point, but we also need to know the slope of my new line. So if it's parallel to y equals 2x minus 7, we see that the slope of this line is 2, which means that my new line is going to have a slope of 2. Okay, so now I know the slope and I have a point, so I can use point slope form. So y minus 10 equals m times x minus 4. Okay, so this is it. We did it. We found a line that's parallel to 2x minus 7, and it goes through this point. But what if we want to rewrite this in slope-intercept form? Okay, so now we have it in point-slope form. So to put it in slope-intercept form, I'd have to distribute this 2. So remember, slope-intercept form means y equals mx plus b. So we need to do some rearranging to get in slope-intercept form. So we have y minus 10 equals, so 2 times x is 2x, times negative 4. 2 times negative 4 is negative 8. And then we want it to look like y equals mx plus b. So to do that, we would add 10 to both sides over here. And we get y equals 2x plus 2. So we did it. We found a line that's parallel to 2x minus 7, has the same slope. They both have a slope of 2. And it goes through the point 4, 10. Okay? We could check that by graphing on both those lines on Desmos. Or we could plug in the point x equals 4. 2 times 4 is 8, plus 2 is 10, so we can verify that it does go through that point. Okay, so the last one that we'll look at today says write the equation of a line that is perpendicular to y equals 3x minus 8, but goes through the point 6, 12, and it wants to write our final equation in slope-intercept form. Okay, so perpendicular. So first thing is, we see the line that they gave us has a slope of 3, and so we talked about how to find a perpendicular slope would be to find the opposite reciprocal. So we would flip it, and then it was positive 3, so now it's going to be a negative 1 over 3. So our new slope is going to be negative 1 over 3. All right, so now we have a slope and we have a point. So let's use point slope form. So y minus 12 equals negative 1/3 times x minus 6. Okay, so this is it. We did it. We found the equation of a line that's perpendicular to our original line and goes through 6, 12, but the question wants it in slope-intercept form. So now we would have to distribute like we did on the last example. So it would be negative 1/3 x, and then negative 1/3 times negative 6 would be a positive 2, and then we still have our y minus 12. Slope-intercept form has y by itself, so we would add 12 to both sides. So it would be y equals negative 1/3 x plus 14. Okay. Now, we could check this a couple different ways. One way we could check this is by graphing it. We could graph this line that we just created in Desmos. We can make sure that it is indeed perpendicular to the original line and make sure it goes through 6, 12. So I'm going to do that real quick, and I'll show you what that looks like. Okay, so I went ahead and I graphed the original line, y equals 3x minus 8, and my new line, y equals negative 1/3 x plus 14. I graphed both of those in Desmos. We can see right away that when they intersect, we see this right angle, this 90-degree angle that was created here. So we can see that they are indeed perpendicular. And then on top of that, I went ahead and graphed the point 6, 12, and this green line, that y equals negative 1/3 x plus 14 goes right through the point 6, 12. And so I know that I did it correctly. Okay? All right, so good luck with your activity today. Let your teacher know if you get stuck or need any extra help, and hope you guys have a great day.